For probability rules, there's a couple things I want us to study. Okay, sometimes we're going to use the probability of A and B. For this purpose, let me just say the probability of A and B. So keyword and. Let me actually highlight the word and. It's very, very important. When I have the probability of A and B, it's going to be the probability that A happens times the probability that B happens. Okay? Probability of A happening times the probability of B happening, assuming they are independent. What does that mean? That if I drew this in a Venn diagram, they're separated. Okay? Another thing is that one does not affect the other. Okay, so assuming they're independent, probability of A times probability of B, that's probability of A and B. So and, the word and, implies multiplication. But there's another rule that we're going to be using is or, probability of A or B. Keyword is or. So whenever you're looking at probabilities, I want you to pay attention. Is it A, is it and, or is it or? Now for this one, we're going to add. I'm going to say probability of A plus the probability of B. Now, when we say the word or, these two don't have to be independent. Okay, what does independent mean? That they don't affect each other, or as a matter of fact, these two we can say they might overlap a little. Now, if they do overlap, because there's going to be two cases, I have event A and event B. They don't overlap, but I could also have event A and event B. When they don't overlap, we call that mutually exclusive. They don't affect each other. They do overlap. We don't call it mutually exclusive. Now, for probability of A or B, I'm going to add the probabilities. However, I'm going to subtract because keep in mind, what if, let me highlight this in green. If I add probability of A plus probability of B, there is one section I'm going to be adding twice. So I have to subtract it once, right? Because I don't want to include it twice. So I'm going to subtract probability of A union or intersect B. Remember, A intersect B is the area that is in probability of A, but it's also in probability of B. Okay, so again, when we use the word and, we multiply it. When we use the word or, we add. However, when they're not mutually exclusive, they overlap. So we have to subtract the overlap. Okay, so for this one, we're going to say it for question number 29. Events A and B are independent. Find the missing probability. I have something about probability of A, something about probability of B, and then something about probability of A and B. So I'm going to say probability of A and B. That's what I'm solving for. It's equal to, I know it's probability of A times probability of B. Okay, so let me substitute the values that I know. Probability of A and B. I don't know what it is. It has a question mark. I learned back in algebra, when I don't know the value of something, I replace it with X. So I'm going to say this is X equals probability of A is 0.6 times probability of B is 0.35. Ah, that's going to be easy. I can easily solve for X. 0.6 times 0.35 is 0.21. That was easy. Let's take a look at question number 30. Events A and B are mutually exclusive. Okay, so that means they don't overlap. Okay, find the missing probability. I have a keyword here, or. I know probability of A is 0.4. Probability of A or B is 0.9. And I'm solving for probability of B. I don't know what probability of B is. I learn that when I don't know the value of something, I replace it with a letter. I call it X. And I remembered the formula that probability of A or B is equal to probability of A plus the probability of B. Now, I'm not going to subtract probability of A intersect B. This last part, according to my formula, I don't have to subtract it because they are mutually exclusive. That means they don't overlap. Okay, probability of A or B is 0.9. Probability of A is 0.4 plus X, because I don't know what probability of B is. Okay, so what will you do to solve for X? What will you do to get X by itself? I'm not going to divide. I'm not going to multiply it. I see in this case, I'm dealing with pluses. I'm adding. So what's the opposite of addition? Okay, let me subtract. So this 0.4, let me move it to this other side as minus 0.4. So I'm going to get that 0.5, it's equal to X. That was not bad.